Hey everyone, today we'll be talking about mainly testing in PHP using PHP unit. And because Laravel is popular, obviously, we'll be talking about testing in Laravel. The specific topic that we'll be talking about is we've had a pretty large project that we had to cover with our tests. Obviously, when we want to develop quickly, we usually don't write tests because we want to get towards the solution as quickly as possible. However, due to the nature of the project at Partners, we'll be describing the project a bit later. Writing tests is actually crucial for us. Before getting on to that, we should, though, talk about what testing is, obviously. Well, at first, let me ask you a question. How many of you did actually ever write a test? Good, that's like 40%. How many of you are actively writing tests when you develop? Like 10, 20%. Okay, how many of you enjoy writing tests? It's like 5 people, okay. Good, so you probably do have a general idea, some of you, what testing is, but there is a technical definition, obviously. Obviously, it's running code in an automated way. That means I can run it anytime I want. Obviously, I could schedule running the tests anytime I want. Then it's deterministic. Obviously, when you test something, you have an expectation and you have a code that executes, and then you have a expectation. Obviously, there's a pair. And the result of running a code should always be the same. And the last is a repeatable way, sort of correlated to the automated thing. We should be able to run it as many times as we want. The result obviously should be the same. If it's not the same, there's a problem. And it's making sure everything works as intended. Obviously, that's sort of the main reason we write tests. Is to make sure that the code that we've developed is running the way it should. We're obviously developing further, so we might actually make changes to the code that was previously tested. If we already had tests for that, it could help us find possible issues. That means we could be forced to edit those tests, add more tests, or perhaps if we were developing and we found a bug, perhaps we need to change those tests to actually reflect the bug fix that we have. Now, obviously, there's the other side. There's a technical side, and there's the approach or the benefit of testing that is for us. For us, meaning as a company, Partners. It is allowing a CI/CD flow. That means us at Partners, we adhere to some strict rules. That means every single change goes through a merge request. That means it goes through a code review. But before going to a code review, we actually run tests on those changes. And as well as the other thing, no bug fix, no feature, nothing gets into production without being tested. So. And the third thing sort of is we can deploy into production basically 10 times a day without any issues. The second thing is ensuring our stack is up to date. We're trying to use the newest technologies. Developers love to work with the newest technologies. That would be obviously for us Laravel 11, PHP 8.4, PHP Unit 11. And obviously minor and major package versions that we rely on since we're using open source. That means we could, it makes it easier for us to update those packages and then catch potential bugs or changes that occurred in those packages that we relied on, so that our website would still be running. And the third thing is testing an isolated microservice architecture. It's sort of the approach that the company is slowly taking. We run many services that we develop in the company. Each has its own set of rules. That means each lives in its own little world, so to say. That means it has to be tested on its own. And we want that because every single application must be able to live on its own, so to say. Besides that, Jakub Potocky, as Paolo said. I'm a full-stack developer specializing in Laravel and Vue, two technologies that I basically love due to the development experience that they bring. It allows me to write code quickly and get towards the result as fast as possible, basically. I'm working at partners, which many of you probably are surprised. We are actually using Laravel, we are using Vue. We have a couple of applications running on those two frameworks. We use TypeScript in all of our projects. And we also have some C# projects specifically in .NET. Besides that, I am an open source contributor and maintainer. Luckily, this year marked my first contributions to the Laravel framework, which makes me pretty happy. Besides that, I actually maintain a SmallView package, which marked 300,000 downloads last week. So, there's a project, obviously. The project has been in active development before I got into partners. What I should say, I've been working with partners for 6 months now. So before I got into the project, obviously, it was in development for a bit of time. The good thing about that project is it was basically a greenfield, so we started from scratch, had a goal specified, what we wanted what we wanted the project to do. So as I've mentioned, it is an internal project. That means we do not provide services for outside the partners. The project is purely for people that work at partners or directly are some sort of service providers for partners. The project is very important because, as a specific word says, we are handling authorization. That means any sort of user, any sort of other thing is reliant on the project. So that means we need to make sure it works correctly. There's no downtimes, there's no bugs, there's no unexpected problems. And also internal and external services. That means we have external projects that are connecting onto the service as well in some specific way. What I should say specifically, I cannot be concrete about some of these things that we're using in the project due to the nature of partners as a company. We take security and cybersecurity very seriously. The one thing that that's also specific for the project is we're adhering to a RFC-defined error handling. That means whenever an error occurs, we must respond in a specific structured. We must use a specific structured response to that. The project has been in development for about 6 months before I got into it. Obviously, there was really not that much time to write tests at that time. We'll actually get to some specific numbers in a bit. So there was low cloud coverage and there were basically little to no tests. So it was working, but we couldn't be 100% sure that it works the way we wanted it to work. And one specific thing also, we use a private composer package registry, which sounds great, but in fact we're just having one private composer package, which sort of works as a repository for some common things that we use across multiple Laravel projects. Now there are goals for me as a developer who just got into the company at the time. The first goal is understanding the project. For me, writing tests was an absolutely great way to understand the project because it was something I've never worked with before. That means I had to thoroughly analyze every single thing that was in the project and then find out that actually some parts of the project are not testable because they were not written with testing in mind. Ensuring long-term immutability. It's a brand new project. We wanted to have it running possibly forever. So writing tests could help us with that. Discovering and fixing bugs, nothing surprising. By discovering and fixing bugs and doing refactoring obviously meant I introduced more bugs which I had to fix. So I actually wrote more tests for those bugs that I've introduced. these things happen, unfortunately. And maintaining a quick feedback loop. Because we want to move quickly, we want to be able to run our entire test suite as quickly as possible. The one thing that we sort of do is we develop locally, and then when we push to a branch and create a merge request, our pipeline automatically runs those tests, and it runs them really quickly. You'll see in a bit how fast exactly that is. For me, obviously, the more tests you write, there's the disadvantage of that, the longer they take to run. Now, there's an initial setup. Obviously, we started the project with some specific technologies. Some of them I mentioned before. That'd be Laravel 11, which we're trying to update pretty often, PHP Unit 11. Xdebug, that would be our coverage driver at the time of starting my work. Laravel Dask, so obviously I'll be talking in a bit. We're not only doing unit tests, feature tests, we're also doing end-to-end tests as well. So for that, we've decided to utilize the first-party package Laravel Dask. Docker, obvious preference for most developers nowadays. I mean, if it works on my machine, it should work elsewhere, so we're just shipping our machines, basically, with Docker. And Orchestra/Testbench is a PHP package that serves as a tool for testing packages standalone, which we use for the one package that I've mentioned before. Now, there are multiple types of tests. For us, unit tests are the priority right now. That means testing the smallest possible unit that's available. Obviously, most of the time that would be a single method for a class or a single function or whatever. And obviously, trying to mock all of its dependencies, so we're only strictly testing the single method or function. Then our feature tests, obviously, that means whenever we're testing and we're not doing unit tests, that means just testing the smallest possible unit. We're likely starting to do a feature test. The most specific feature test would be testing something and then asserting against a database that some sort of entry was created, for example. And there's end-to-end tests. Obviously, the project when you look at it from a front-end point of view, really that has basically a login form and that's it. But still, we want to make sure it works as intended, so we use a Chrome driver for that, which spawns basically a Chrome instance and automates it through the Laravel Dask. So basically, you click a button, you expect something to happen, blah, blah, blah. This is basically our pipeline that runs on merge requests. This is a pipeline for our production branch. So nothing super surprising about it. We set it up. We built the test container. We run PHP unit. We run a security check. That means we check Composer package installations, whether, as we know, issues arise in various packages. So we test for that during the pipeline to make sure that a insecure or a security risk does not get onto the production branch. We run Selenium testing and we run static analysis. We'll talk about that as well. Obviously, if you adhere to a specific coding standard, writing tests becomes easier. We'll talk about it a bit later, and the rest is not really important. Now, as I said, there's a starting point, 148 classes. Basically, I mean, we can say that's a pretty minor project. What's important to say that a large amount of sort of functionality that we rely on is provided by an external package, which I will not specify for the security purposes. At that time, we only had 41 tests, basically nothing. Out of those tests, we had 149 assertions in total. The code coverage was at around 20%. For us, code coverage is basically the pretty important metric due to the fact that we were writing unit tests. And the time those tests took was 26 seconds. So, I mean, for 41 tests, that's already pretty bad. Now, there's some suggestions that I'll make to write better code, and possibly you don't necessarily have to write tests as your program. like side by side. But if you program with testing in mind, you would avoid refactoring in the future, which may be helpful. Obviously, you might not be the one that writes tests for the functionality that you've just programmed. These things happen, which obviously was my case. I mean, I've once thrown into a project that someone else basically programmed. One thing that we really like is going strict. Sort of when you already program things, during the development you get a lot of type errors, which helps us sort of write less tests where this sort of magic retyping happens when you throw a string 0 and it gets recasted to a boolean or something like that. So we really try to avoid that. All of our entire project is strict by default. And one other thing I'll say, we also utilize value objects for that. For example, string is sort of a generic example, but we also can have an empty string of length 0, which we try to avoid. So for that, for example, we have a non-empty string value object, which gets validated on creation. Unnecessary complexity should be avoided. I guess I should go full screen. As you guys probably seen, I really don't like doing presentations, so instead I've spent twice the amount of time to program a Vue application that does exactly that. Unnecessary complexity should be avoided. It's sort of obvious. It's pretty simple for us. I mean, if we create a request, we throw it into the function and it takes something from it. This is annoying to work with, mostly because you have to look into the entire request to see what rules it has to actually find out what possible variables, what possible data it contains. And obviously, also when testing, when testing a function like this, you should mock the login request and blah blah blah. It's sort of annoying. Instead, when we just sort of refactor it to obvious variables, it's much clearer what the method actually requires, and it's in fact easier to test. And one thing, the reason we also don't like doing that is because all of our requests are final, but we'll get onto that topic a bit later. Now, dependency injection simplifies testing. We're using Laravel, the dependency. The service container is pretty handy with that. Obviously, we type in the dependency, and we let the Laravel take care of that. This is also super helpful in tests when we're creating mocks, because if we instantiate, for example, the class under test through the service container, before that we created mocks. We'll get into an example later. Sort of Laravel takes a bit of the boilerplate away for us. Splitting up simplifies unit testing. So nowadays it's kind of common to split code into a lot of smaller sections. So when we have a testable class that has a method and it relies on 2 services, it's easier for us to mock those services and then make assertions based on the written values of those mocks. But at the same time, if the functionality is pretty small, testing those small services, that in this case service 1 and service 2 on their own again becomes a bit simpler. And read-only and final classes are not ready. This is a pretty important thing to say. Final classes are classes that cannot be mocked. This is super annoying. PHP 8.1 has been released in November 2021. That's been almost 3 years ago. Unfortunately, basically all of us rely on Mockery, the most popular package in PHP for mocking classes. Unfortunately, the package does not support that. I've done a lot of research. Unfortunately, did not really find a good solution for this issue. And read-only classes are classes that cannot be extended by non-read-only classes. The way PHP unit or Mockery works is that it extends the class that we're mocking, and it extends it with a non-read-only class, unfortunately. So that creates another issue. There is an ongoing issue on the Mockery GitHub, which I've actually posted like 3 or 4 months ago, whether there's something we could possibly do to help out with the development. Unfortunately, there's no response from the developer, so we'll see what happens. Seeders as a preparation for our application. What we have is a few bits of data that we can prepare beforehand. This comes useful when running tests as well, because we don't have to run those migrations all over again. We can basically seed once and use those data if we use some sort of feature tests. So we would have the database prepared for a bit. Obviously, maintaining seeders is annoying. Clean code helps, as mentioned previously. For us, we're using Pint, the Laravel tool for coding standards, which comes basically with a predefined set of rules that are easily configurable. Alternatives are such as PHP, CS, and similar. In our pipeline, we also run PHP mess detector and something else. I don't really remember which one it was. So. Obviously, adhering to a specific coding standard makes it easier to analyze the code, to write tests for it, because you're sort of following a familiar structure of the code. Now, testing itself. For us, structure prevents mess. So whenever we would have a class in the app directory with namespace casts or console commands named, let's say, seed command, we would immediately, or when writing the test, we would make a sort of a mirror of that class. So we would quickly know whether the class has a test by doing some, for example, seed command search. Obviously, the test would pop up immediately, and it also allows us to find the class pretty quickly through the structure. Rolling back is quick. Nowadays, using database transactions or the refresh database trait is pretty handy, because we run a test, make various changes on the database to a database transaction, then we can just roll it back, and we don't have to migrate freshly again for each test. Obviously, migrating may be slow. The more tests you have, the more migrations you have, the slower the test itself will become if you're running migrations for every single test. Service container is here to help. That's sort of obvious for some, but we sure like to make these shortcuts where we use the global app helper, but we actually have the Laravel instance available once we set up in the test case. This is kind of handy, because as we'll get to that later, but it allows if we tell the container to for example, use a specific instance of a class in place of an abstract, that means the perhaps service could inject it automatically, the instance that we provided to the service container. We'll get into an example later. Describing your tests is pretty handy. PHP unit has these attributes that specify that this specific test, there's a typo, obviously, it should not have been user service, that this specific test covers this specific class. That helps us with code coverage, because we might actually be using multiple classes, multiple mocks inside a specific test, and then those might actually count towards the code coverage when run, and that might not be intended. So, for example, for this case, the code coverage for user repository should not count, because we're not testing the user repository here. We're going to test the user service. Mocking allows for true unit testing. So since we want to create mocks, creating mocks allows us to make expectations pretty easily. That means if a user service has a dependency on a user repository in its constructor, we can tell through Laravel's helper method create mock that this will not only create the mock, it will also put it in the service container. That means when we actually create the user service below that, the mock would actually be injected into the user service, which is kind of handy. We can avoid those the new class boilerplate, which obviously this approach has a little disadvantage, and that is, if we were to add another dependency to the user service, the container would just make it. We would not get any error, so it still has a disadvantage. Don't repeat yourself. We've seen this pretty often. We'll write a test for every single possible response code. In this case, when we can just instead use data providers. Again, PHP unit has pretty handy attribute called data provider, and we can just specify all the possible data that we'll receive in the test case. That means for basically every single entry in this array, a test will be run with this specific response code. We should test early returns and edge cases. Obviously, a method can have early return, can throw an exception, things like that. So, related to the description thing, and I actually forgot an important thing to say. But we can actually see it in here. The one thing about description that I like to talk about is also making our test methods descriptive. That means it's pretty obvious what they do at first glance. And this also has a pretty great advantage with one thing that we'll talk in a bit. So obviously, when you have an exception, something bad happens, you have early returns, don't forget to write those test cases for that, even though it might be obvious to some. Test must fail if it goes wrong. This is a pretty good example from Laravel. We have a pretty simple validation rule, takes a attribute, takes a value, and if it fails, basically nothing will happen because there's not much to assert in this case. We're only testing a value, whether it's valid or not. So actually we must make an assertion in a test case, otherwise there's really, the test case is invalid because we haven't asserted nothing. But if something wrong were to happen, that means the phone number would not be valid with the E164 phone number format. The test must fail. So we're actually making sure that we also write the failing sort of condition in there as it should be. And this is my little thing to say about AI, fancy words. When being descriptive, that means using the covers class, uses class attributes, and writing a test method name accordingly. It can actually save a lot of time when writing tests. Obviously, this is pretty much the test that I would write when testing the user service. It's sort of like 95% the thing that you would need. You'll just press step and you would save a lot of time. Obviously, when writing 1,000 tests, this adds up quite a bit. Now, the more tests you write, the slower the test suite becomes. The test suite started at 26 seconds, I believe. So ramping those numbers up at around 1,000 or 1,100 tests, we already got into 2 minutes and 50 seconds, which obviously is not bad, but when you're running perhaps those tests locally, it becomes annoying because you run the tests and you have to wait and you're bored, and we like to do things quickly. So if you use a different coverage driver, which is sort of, there's no really, nothing else to choose, obviously. There's not that many coverage drivers, only have 2. Xdebug works as a coverage driver because there's it supports it, but it's low. What we can do instead is use PCOF or whatever it's called. It's a coverage driver which is specifically made for calculating code coverage, and obviously it's like almost twice as fast. So that also speeds up the test suite quite a bit. One note, watch for slow tests. You might be dependent on open source packages, everyone is, obviously. We had a very interesting test case where tests would run quickly. We would get to test number around 800, and then the test would take like 35 seconds for no reason. Opening logs, we actually found out that we had 800, the test number -1 logs, which became kind of suspicious. So if we were to run 801 first test, there would be 800 logs. And what we noticed is that there was a package that whenever a Laravel application instance was created, it would put something in a static variable, which would not get flushed. That meant there was a bug in the open source package, and the developer of that package actually fixed it in like less than 10 minutes. So that was pretty amazing. Yeah. Instead of optimizing tests, we can just run them in parallel. Obviously, that should be the last step. We want to run tests quickly. We want to have a quick feedback loop. So when we've done all the possible approaches that we can towards optimizing, writing good code, the only thing basically that we can do is just run them in parallel, which comes with its own sets of issues. Luckily, installing and running is pretty straightforward. Again, we're running in an open source world, so we just require a paratest package, which is in the Laravel docs, and then we'll just call an artisan command with the parallel option. That should possibly work. There are edge cases where, for example, you might be relying on a storage directory running 10 tests in parallel might attempt to write into the same storage file. So we should avoid those collisions. Luckily for us, there was only one case that we actually needed to refactor a single test to actually run correctly. Not the test, the functionality. And that was whenever the workers are started for the parallel testing. So the way it works, we have a sort of the main PHP process that would be the PHP unit or the paratest instance running. It would spawn additional processes that it would control. Whenever one of those processes fails, it would kill all the other processes. It's pretty simple. It's the way we do parallel in PHP. So. And I don't really know what I was going to say with that, sorry. Perhaps I'll remember. The issue that had, because we want to avoid collisions, every single test worker that is running has its own database if we're, for example, using MySQL. So Laravel actually takes care of that. It creates like additional databases for each worker. That means we can run seeders against the migrations and seeders against each of those databases, have each of them prepared. That means we do not have worker collisions because they might write into the database whenever they want. The one thing that we actually added was like whenever the application is resolving the parallel testing class, which Laravel has, we'll actually call a setup test database callback and just call it console command that seeds the database. The good thing is it actually does not create the database every time, so the command is in fact only started whenever we specifically specify an option to create a database when starting a parallel test, or when the database was not yet created, for example, when we increase the amount of workers. Regarding running tests in separate processes, this again becomes a bit annoying the way, as I've stated before. You have a main process that spawns like 12 workers, for example, 12 additional processes. And if you have a test case that runs in separate process, that worker would create another instance, and that becomes quite a mess. And has its own sets of issues. You just sometimes get a segmentation violation, like there's nothing locked, there's nothing to debug, it just fails, and you just want to cry. Luckily, there's something obvious, like at least you know which test it was trying to run, so there should be something suspicious in that test, even though it's not suspicious at first. Another unfortunate thing, this issue only occurred on Linux devices or in our GitLab pipeline. I was never able to reproduce that on my Mac machine, unfortunately. But the issue was that actually I've created a mock for a Laravel event dispatcher, which was a pretty bad idea. So you should instead use the event fake facade for that. Now, results. As stated before, the project started with some specific code base. So I was not only writing tests, obviously, I was also writing new functionalities. My colleagues were writing new functionalities. So the amount of classes increased during the time period as well. This is where we are now, that's important to say. The amount of tests increased by 1,400 from 41 to almost 1,500, which is quite a lot. The amount of assertions increased by 6,000. So we basically sort of testing almost everything right now. Even though the code base grew up quite a bit, we are now at 73% code coverage and slowly getting higher, hopefully catching more bugs. And the time it takes is 39 seconds. So we went from 26 seconds to 39 seconds, and we increased the amount of tests. It's basically incomparable. Thank you.
Thank you, Jakub.
And one thing, I'll use this for shamelessly promoting. We really need testers. If you know someone who likes manual testing or would like to do manual testing, please let me know. Thank you.
Okay, perfect. We have a lot of questions, and yeah, the one that I was interested in is not there anymore. But yeah, let's pick the shortest one: PHP unit versus Pest, because this is. I know that you've prepared for this.
Yeah, I did. Obviously, I don't really have a preference about that. Obviously, Pest is sort of made as a copy from the JavaScript Jest testing framework. It's built on top of PHP unit. Really, there's not that much of an advantage. One thing that I would really like to use Pest for is the architecture testing plugin. I am someone who, as Miro, I believe, said, I like to use die dumps, but at the same time, I'm also using Ray, and it sort of it happened once, I believe. We actually missed the Ray call, and it got into the production, and that was pretty bad. So architecture testing would really help us out. Other than that, I have no issues with using either of them. So I guess it's just a personal preference.
Okay, there is another one that I'm interested in. How to make my colleagues write automated tests. Like, what's your strategy on that?
Why should you make your colleagues write tests? Shouldn't the management enforce testing? Shouldn't? I mean, the obvious main reason is you want to prevent issues. The one thing that I would say, you should not really be a position to force your colleagues to write tests. You should have a general consensus that we are writing tests and this is the way to go. We want to avoid issues in the future. We want to avoid issues before they get into the production. So the added value is there. Obvious disadvantage is writing tests just takes time. So obviously not every company, not every project can afford the time spent on writing tests. That's just the reality of it.
Thank you. How do you introduce testing into legacy PHP code bases that weren't built with it in mind? What strategies help manage complexity in large, untested systems?
That's an interesting question. I'm not entirely sure whether I have a proper answer for that, but in about a month, the next project that I'll be working on is like a 7 or 8 year old Laravel project built currently on Laravel 9 that has basically no code coverage. The project is quite a bit of mess. There were not any coding standards used or anything like that. So my usual strategy is trying to get to the smallest parts, trying to figure out whether the functions that I'd like to test are written correctly, whether I even can test them. So it's pretty possible that I first have to do a bit of refactoring even before writing tests, which is obviously not preferred. You'd like to write tests and then refactor. I'll have a better answer for that after that project.
Yeah, okay. We will reshare it. Okay, which private PHP package registry do you use and why?
We actually kind of take the dumbest approach. We use self-hosted GitLab, so we use the GitLab package registry, which allows us to manage packages both for PHP and even for Vue or for frontend. It actually supports that, and it's pretty straightforward to use. You just take versions. It's pretty simple.
Okay, Do you use any static analyzer?
We do not yet use PHP Stan or Arastan. It's sort of something that I'd really like to do in the future. We have that planned as well. We will be using a static analyzer.
Okay, what is an acceptable time for end-to-end tests to run? We had about only 20 to 30, but they ran for 10 minutes and they want to die because of that.
I think Cypress, yeah. We actually do have Cypress tests as well. We have a sort of separate guy that writes tests for that because we have multiple applications. So you log into one application, then you get into another application, you do something, and you expect something to happen in a third application. So it highly depends on the specific use case. For us, running one test takes like at least a minute. So I'd say that's a pretty decent number. If you think that those tests are slow, for example, you can easily compare that to a real user simulation of the test. So I'll try to do the same thing as the test does. If I do it quicker, then obviously there's an issue and I should look into those tests, I guess.
Okay, maybe there is a similar or related question. Have you considered to have more test suites, like one smaller, quicker one, and second, maybe including all those end-to-end tests? Or is it a bad approach? What do you think? If they
we didn't consider that. I mean, when we're running, when we're developing something, we're either creating something new. That means there's really not much to run locally, or we're refactoring a specific class, adding functionality to a specific class, which likely we already have some test already written for. And what we like to do, the main reason why we did all the optimizations and why we started using parallel testing is to be able to run all of our tests as quickly as possible. I mean, when you run those tests locally in like 40 seconds, that's like pretty fine for us. We did not consider writing a specific test suite that would just contain perhaps some smaller tests.
Okay, maybe last question. Do you use SQLite or MySQL for running tests?
We use MySQL. The main reason is our production uses MySQL, so it's kind of a preference to use the same technology both for testing and both for running the production code. Who knows, something may be different in SQLite than it is in MySQL, so we'd like to prevent those issues.
Can only confirm that. Okay, thank you very much, Jakub, for your talk and for your answers.